Hi, this is Mr. Poston, and today I wanted to talk about how to convert numbers into scientific notation. What I'm going to go ahead and do is, let me go ahead and get my pen here, and let's see. We want to first talk about why we will want to convert numbers into scientific notation. Let me go ahead and write this down. So number one, the question is why convert? And to give you an example of this, in science class, especially in chemistry class, we're going to be talking about numbers that are very big and very small. So for example, here's a number, 602, 1, 2, 3, 4, 5, 6, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. It's got 21 zeros behind the 2. Now, as you can see, this is a huge number. It turns out this is actually called Avogadro's number, which we'll talk about when we talk about the mole. But what you need to know about this number right now is that it's really big, and the way to make it a little bit more manageable is to get rid of all of these zeros. So what we're going to do is we're basically going to eliminate these zeros. And how are we going to do that? Well, we're going to have to move our decimal point, which is now located right here, all the way over to here. So I'm going to go ahead and move my decimal point and count 1, 2, 3, 5, 6, 7, 8, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23. This should be 23 times, maybe miscounted. But when I move it 23 times to the left, that allows me to basically drop off these zeros, and I get the number 6.02 times 10 to the power of 23. So what does this mean right here? This is called scientific notation or exponential notation. It means that I'm basically multiplying it times 10 23 times. So think about it like multiplying it times the number 1 with 23 zeros behind it. So if I have this number 6.02 times 1 with 23 zeros behind it, I get this big number right here. So a little bit of terminology here. The first number that we're talking about here, the 6.02, is called the coefficient. So it's called the coefficient. So this is called the coefficient. And this number has to be between 1 and 10. So it has to be between 1, has to be less than 10. So I'm going to call this number x. It has to be greater or equal to 1 and less than 10. So it could be 1.0001. It could be 9.999. It could be equal to 1. It cannot be equal to 10. So this number 6.02 is between the number 1 and the number 10. It's less than 10 and greater than 1. And that's what we want to have right here. So this is correct scientific notation or exponential notation. Now you'll notice that this number up here, the exponent is actually going to be positive. This is called our exponent, right? Or power. And it's positive because I moved my decimal point to the right 23 times. What does that mean? It means that this is a very big number. So whenever the number up here, the exponent is positive, it means that I move my decimal point to the right. That makes it positive. If I were to move it to the left, it would make it negative. Let's do one more quick example. Insert new slide. So let's imagine that we were to move our decimal point to the left. And if I get my pen working here again. Alright, so let's say that we've got the number 0.001. Well, is this number greater than 1? No, it is less than 1. It's definitely less than 10, but it's not greater than 1. So we're going to have to move our decimal point right over to here, right behind the 1. The way that we're going to do that is we're going to go ahead and we're going to move it. So I can get my other pen here. 1, 2, 3 times to the right, which gives us the number 1, right? So we get the number 1, and so that's going to equal to the number 1 times 10 to what power? we moved it 3 times to the right, so that's going to be -3. So there's our final answer for this one here. And so once again, when you move it to the right, you're making this number bigger. So you have to make this number up here smaller to basically balance that out. So the fact that you made this number bigger. So this number does not equal to 1. It equals to 1 times 10 to the -3. And what that means is that you basically have 3 zeros, 1, 2, 3, on the left-hand side of that 1. So this is a very small number. So if you have a number times a negative exponent, it's going to be less than 1. If you have a number, for example, 1 times 10 to the 3, that is a big number. It's going to be greater than 1. Get my eraser here. And so in this case, what would the number 1 times 10 to the 3 be? Well, that would be equal to, give me my pen again. That would be equal to the number 1,000, right? Because notice the number 1,000 is the number 1 with 3 zeros behind it, 1, 2, 3. And how many zeros do we have here? We have 3 zeros, so it's 1 times 10 to the 3. These two numbers right here are equal. And we're going to go ahead and we're going to pause there.